Okay, so last lesson we looked at integration by substitution, and we are now moving on to integration by parts. Okay, so this is one of our second sort of big techniques. Um, what this is a rearrangement, if you like, of the product rule that we use when we differentiate, and we can use that to make a sort of an equation um, to integrate things. Okay, there is a proof for this here underneath, but you don't need to know this. Okay, this is given in your formula booklet, but it might look slightly different to what's presented here. And we use integration by parts when we have sort of like two pieces sat next to each other, two functions of x being multiplied by each other. And notice this doesn't seem to fit any of the situations that we saw before. Okay, so if we had something like this, integration by parts is the way to go. And what we do is we assign one of these pieces u, and we assign the other piece, I will call it dv. Okay, I will refer to it as just dv. The u part, we're going to differentiate, and the dv part, we are actually going to integrate. And I'll talk to you about how you can pick which one's which in a moment. But essentially, we look at this and we think if one bit differentiated and the other bit integrated would work well, that's what we want to use, integration by parts. So, for example, this one here, this would be my u part, and this would be my dv part. Notice x differentiates very easily, and cos integrates quite easily as well. And this would be the same as, so the integral of all of this would be the same as uv. Notice uv is not being integrated or anything. You just have to multiply them together. You have to find what v is first of all. That's going to be sine. Okay, dv integrated becomes v is sine. And then you have a minus, and then you have some other part here, v. So that would be my sine x again. And du, you have to differentiate that part. So I have to pick two pieces, one to differentiate, one to integrate, work them out. So I've got four different pieces, and then plug them in to this. So let's show you what I mean by that. So this is our u piece, this is our dv piece, and I will often write something like this on my piece of paper. U equals x, and again, I'll tell you, why in a moment. Dv equals cos x, and then while I'm here, I'm going to do du. Make sure your du does actually look like a u, because that's a very easy mistake to make there. And then also v. So du is 1, x differentiated is 1, and this one you're going to have to integrate because its derivative should be cos x, so it must be sine x. And now these are your pieces. uv minus the integral of v du. Okay, this whole thing here, this is just du. I normally won't put this dx here. And this dx is a notation thing. It means integrate with respect to x. So actually, I will write this as uv minus the integral of v du. That's how I think of it. So let's have a look. We assign those pieces there, we work out the other pieces, and then we plug it all into this formula. So uv, you can do sort of something like this, will be x sine x. Now that bit doesn't need to be integrated. Look, there's no mistake there. There's no integral sign. So that's just x sine x minus the integral of v du. Well, v is sine of x and du is 1. So 1 times sine x, that's just sine x. Do you notice how that's not really a problem? Integrating sine of x is not really an issue for us. So x sine x, the integral of sine of x is minus cos of x. Okay, so final answer, I'm going to have x and then sine of x plus cos x, and it's indefinite integration, so we should have a plus c as well. Okay, the fact that x differentiated to 1 meant that this multiplication turned into a really, really nice multiplication. It just turned into sine of x. And that's why we were able to sort of finish off this question. Another example then. And it's time to introduce you to sort of the priority for which part is u. So when we are assigning u, the priority is late, L-A-T-E. L is logarithms. I'm just going to say logs. A is algebra. So things like, x squared, something like that. T is trig, and E is exponents. So U is going to be logs. And specifically here, I mean, natural log, okay? Because it will always be natural log that you get asked about. So that's U. And now look at the format. So if you have one piece that you could differentiate, and it's sat next to another piece, another function of x, to integrate, that fits this format. This here is u dv. So we say the integral of the form u dv, yeah, you do this integration by parts thing. So dv is x squared. And now we can find out the pieces. So I am differentiating with respect to x, but I just don't think it's helpful to put that there. It just looks more confusing. So this becomes 1 over x. So maybe now you see why, if we can, we like to make the u part the natural log, because it differentiates really, really nicely. It doesn't integrate very nicely, by the way, but it does differentiate very nicely. This one here, x squared, integrate x squared, that's not too bad. So x cubed over 3. Okay. You've now got the 4 different pieces, and we need to use the rule. So the rule is the integral is equal to uv minus the integral of v du. Very confusing when you start, lots of u's and v's and stuff flying around. Okay, lots of practice for this one, essential. So uv. Now that's not very nice, but the good news is you don't have to integrate it. That product, that bit's done. So it doesn't matter if this bit looks messy. So x cubed over 3, I'm going to put that at the front, and then natural log of x. So that is the uv part. Minus the integral, v is x cubed over 3. And du is used here as 1 over x. So do you notice that there's some interplay between these parts here? So you can actually effectively do that. And then you have x cubed over 3, natural log of x, minus the integral of x squared over 3. And the x squared over 3 bit, which you still need to integrate, isn't too bad. Okay, increase the power by 1 and decrease by the new power. We're going over here. X cubed over 3, natural log of x, minus x to the power 3 over 9. Okay, because I've now integrated that part. And that is my final answer. So it's like a roundabout way to go around integration. It's very different to the substitution that we've just done, but it's a technique that works really, really well when you have like a product situation. So you use product rule with differentiation. When you talk about product with integration, you're talking about integration by parts. Okay. And don't forget to use this sort of list of priorities here. So pause and have a quick go at this one here. So your final answer should be as follows. Don't forget the plus C. So your U bit was X, because that differentiated away. It's the A for algebra, okay? And the other part, e to the x. E to the x integrated really, really nicely. So e to the x was your dv part, and then also your v part as well. X, ex. Okay, minus the integral of 1 times. Well, when you integrated this part here, it was very much the same. Okay. Next question. Let's have a look. 4x sine x. So what's going to happen on this one? 4x is going to be your u part that you want to differentiate, and cos is going to be the part that you integrate. So uv, yeah. So you need this. This will sine x will become minus cos x. So that's how you get that line there. That's uv. 4x differentiated will be just 4. So when you do your v du, you'll get this part here. you can sort of, if you have a negative and a negative here, you can just make it a plus sign straight away. Seem to be missing some of the answer. I'm not sure why that is. If you integrate 4 cos x, you'll get 4 sine x, won't you? So your final answer would be like that. Another one, let's just do one more example. So u is equal to x. How do I know that? I'm using the LATE thing in my head, and I'm going algebra comes before trig. dv equals cos 2x. So du is 1. V is sine 2x, but there will be a chain rule, and I have to compensate for that. It should be a half. You need to make sure that you're confident with something like that integration there before you continue, okay? Because it will be expected. You're going to do uv, so you're going to have a half x, or you can have x over 2 if you like, a half x sine 2x minus the integral of v du. Well, the du is 1, so that you just get left with that v part there. Okay, when you integrate this one here, I'm just trying to think if we could do a little trick here to make this a little bit nicer. No, I suppose it's fine. Let's keep it that way. So cos is going to go to minus. So I'm going to have minus cos 2x. And I will have to compensate again. That will actually have to be a 4. Check by differentiating. So hang on, that should just, I've integrated now. Check by differentiating this result here. It will actually take you back to this one here. Okay, so you have to compensate again. You end up with a double negative. So final answer should be a half x sine x plus a quarter cos 2x plus c. Okay, just going to reveal a couple more questions on the board. So these are sort of, this kind of thing is how it might appear. I would say something like those first 3 questions would be really, really common. This one here said integration by parts twice. We will come on to that a little bit later. So, wow, we're actually there now. Integration by parts twice. Tricky if you have to do this one. The reason why we might have to do this is sometimes you will work through the process and do you remember that you get this integral over here? Sometimes this integral, the way to do that integration will be to do the thing again, okay? To do the integration by parts again. I think I'm going to reveal this one for you and talk through it with you. So let's approach this question. LATE says that x squared should be the u. So while you're there, du is going to be 2x. I don't like the way they've written this. I would write this the other way around. dv is e to the x, so v is e to the x. So that sounds pretty normal. You plug these numbers into the formula, and this is what you get. Now, the bad news is you cannot deal with this part here. Why can you not deal with this? Because that's a difficult integration. You still have to integrate. That's what the sign means. You still have to integrate 2x ex. But that, so for this one here, you can actually use the product rule. Sorry, not the product rule, the by parts rule on that. So what we do is we keep this to the side for the moment. Okay, we just keep that to the side. And now we tackle that part there inside the red box. So we'll repeat the process again. LATE says 2x should be the u part. du would be 2. dv should be e to the x, and v will be e to the x. So that red box, when you pluck out those numbers and put it into the formula, you will get that one there. Okay, so you get your uv part here. So that's your uv minus your integral of v du. So what's happened here is now you have 2e to the x. That part there, you can actually integrate that, can't you? It's just 2e to the x. We couldn't do that before because we had this extra x here. So that was not something that we could have done before. Okay, now let's try and bring the whole thing together. So the question was, find this one here. Well, we said the answer is this part that we left alone, that was already done, minus this part. And then this part is actually the same as all of this here. So it should be x squared e to the x minus, keep that minus sign there, put all of this part then in brackets. It's that part there. And you'll notice that you get lots and lots of terms. You might even notice a bit of a pattern, x squared 2x2. So you can sort of use it as a little bit of a guide for if your answer sounds right or not. But it's near enough two questions in one. Okay. The only further thing I would say is if you're on the FM route, this would be a really good time for you to have a look at tabular integration because it will show you a slightly quicker way of doing this. So pause the video now and have a go. This one will require 2 steps. You can see it will require 2 steps because x squared 2x2. It will have a similar sort of thing going on to the last one. Pause the video and have a go at that one there. So assuming you've done that, we get just this one here. Okay, I'm not going to go through exactly this one again, but you would repeat the process as we've just done here. And now you should be in a position to have a go at 11F. The maths is getting quite hard here, so the hours need to be put in at this point, okay, before moving on.